appreciate you setting this up, and I'm really looking forward to getting back together in 2021 and being able to see everybody in person. So thanks again, Ron. What I thought I'd go over today is, why cloud, why customers look at cloud, go into the AWS cloud design, what's unique about our infrastructure, talk about our climate pledge and what AWS is doing in that space. And I figured, with 45 minutes, that's what we really have time for. So to look at what customers are looking for, why they look at cloud, years ago, it was a lot about cost. Basically, can I reduce costs? More and more, the discussions I have with customers is about agility and increasing that, ability to make changes to rev applications. And so that has been a big change. Now, if you're doing things on an internet scale, that's something we learned a while ago that was definitely needed. And if we look at back in the early 2000s, there was a company that saw the future of sales was online, and they started doing online sales very early 2000s. And I think it was 2004, they did a big push at Christmas time to get everybody to go to their website and buy toys. And they had provisioned 10 times as many servers on premises than they had ever had as far as a load goes. And fortunately and unfortunately, their marketing department did a really good job. And a lot of people went to the internet to buy stuff. At that time, 2004, I hadn't bought anything on the internet yet. But people went there. And, part of the thing, I don't know if you've thought of who the customer or company might be yet, but this might help. They had part of the promo was if you spent over $100, you got a free Tickle Me Elmo doll. And so that really drove the traffic, evidently. And they were down for 2 weeks with basically the number of customers coming to the site trying to buy toys at toysrus.com. It basically denial of service their website. It took them 2 weeks, and they had a really good partnership with their provider, and they were able to get servers, added. And so with only 2 weeks of downtime, they were able to turn around, which is actually pretty good at that time, because it often will take you, months to get servers. So it showed if you want to do internet scale type things, it's very difficult, and it helps to have a cloud type environment. The other thing is once that Christmas time is over, you probably don't want to have that capital expense for all of those servers. It would be nice to be able to stop, to do that rental type model. And that's really why customers look at cloud is, costs, improving the reliability, security, increasing that agility. So if we look at AWS and why customers work with AWS, it really has to do with our breadth and depth of services. If you think about, we started in 2006 doing cloud services. The first tool we added was S3 storage, cloud storage. And in that cloud storage, if you think about, what that offers today, I can get a gigabyte of storage in S3 for 2.3 cents per gig per month. It's, storage that has 11 nines of durability, which means, I should never lose a single bit of data in that storage. It has a rather high availability. I'm trying to remember exactly how many nines of availability, and I'm drawing a blank, but it's highly available. But the thing that's interesting to me on it is if I want to put up a 1 gig website and run that for the whole year, as long as I, already have my domain name, and my traffic stays under, a couple gigabytes a month, I will spend under 30 cents for that 1 gigabyte static website for the year, right? That is pretty amazing to be able to put up a website for that low cost. And that's some of the things that the cloud storage can offer. And it's quite scalable as well as far as the number of users that could hit that site. So that's our first service that was launched, a little over 13 years ago. But there's a lot of other things that come with that now because of that experience. Our CEO, Andy Jassy, states, there's no compression algorithm for experience. And what that really means is as you do these things, you find a lot of things that can be improved upon in process and in hardware and in software. And that is something that we have that has really made a difference. Over 203 security compliances. We have things such as one of the unique things I think about AWS is we do price reductions that are largely without competitive push. When we reduce our cost, we pass that cost reduction on to customers. And we've done that 85 times so far since 2006. Other things that are interesting is, the large ecosystem of partners we have, from just ISV partners that build software. We have over 1,600 ISVs offering over 4,500 applications in our store. So there's some pretty interesting things in that experience that we have. And of the 175 plus services that we offer, in 45 minutes, I would have a hard time choosing which ones to go into and talk about. I would certainly not be able to cover all 175, and I actually don't know about every single one of them. The cloud is so broad that it's you have to specialize. So I thought I would go into the basics of understanding what works beneath the cloud, in what makes us unique. So basically, going into some of our unique global hardware and software that runs our cloud. So it starts with the network, and having a world-class high-performance network, that's certainly going to be an important piece, because when you think about these building blocks that I'm going to talk about, everything that you add runs on top of those. So any little bit of performance I can get in that underlying hardware or software is going to be improving whatever that higher end service that you build on top of it is. And there are quite a few things that we've done. For one, in the network space, it starts with that global infrastructure worldwide. And if you think about why it might be important to have this global infrastructure, certainly there's the compliance and data residency. But more importantly is we have physics to deal with, which is the speed of light. That's our limiter in networks, because latency is important. And so if I look at that latency, I want to have extremely fast responses for my customers. In the US, we're a little spoiled. I think we will wait on a website for one and a half seconds, maybe 3 seconds. And if it's longer than that, we won't stay on that website. I don't know what it is. I haven't been to a third world country and tried to use the internet. I don't know if they have the internet, but I do know that in some countries, they'll wait up to 7 seconds for a web page to load. I know here, if I go to a web search engine, if it doesn't respond immediately, I don't feel that that's a good search engine for some reason. So if you do go to our search engines of all the different companies that have them, you'll notice they pop up and respond rather quickly as far as the first page load and all that. That's because we want that fast response. But to get that, you have to be close, because you need low latency. As a matter of fact, one of the things that's we've done uniquely in our network is we found the traditional router mechanisms, or the way a router would work, is the packet receives into a queue, and then when the router has time, it grabs the next, first in, first out, and it would grab that packet and then route it to the right spot. We found that is too slow, and where lots of routers have problems is, that queue length grows, and then it takes too long, and you have latencies. We've moved to a different type custom-built system for our routing. We basically take a hash table, and as we get that packet, and we look up its destination it wants to go in the hash table. If that doesn't exist, we go to find it, and that takes too long, basically, and that packet gets thrown away, but it gets added to that hash table. So that first packet doesn't ever get delivered if it's never been sent to that route before, if it's the first time that machine has tried to talk to that area. But then once that address is in the hash table, all of them are immediate, and there's no caching. And so it helps our latency to be quite lower, as well as it really rids the drop packets. Even though that first packet is dropped, the number of drop packets is significantly reduced. And so by changing these different ideas, we're able to increase that speed. Now, if you look at our global environment, we're based in 24 regions with 76 availability zones. And if I go into what I think is some of the magic of the AWS cloud environment, it has to do with availability zones. because in a region, an availability zone is a group. It's either one or more data centers. So maybe a cluster of data centers in an AZ. And so in a region, I generally have 3 AZs or more. And that AZ environment, if I just take one AZ, that is a cluster of data centers. They may be across the street. We basically stop building, stop adding servers to a data center at 50 to 80,000 servers in a data center, and we build another one, across the street kind of thing, and they're well connected, and it's done to keep the blast radius, minimalized inside the AZ. But that's how we build and scale out that AZ environment. But the real neat thing is these AZs are tied to each other in extremely well-connected networks. And so from an availability zone, I am far enough away that I'm in a different power grid scenario, and they're fed by at least 2 power grids to each AZ, but there's different power grids from the other AZs. They're in different floodplains, so they're far enough apart that from a disaster situation, one type of natural disaster is not going to take out 2 availability zones. But they are close enough together that between the availability zones, we have single-digit millisecond latencies in the network traffic. And so that lets us do a lot of things. If I look at, from my history of working in IT, I've often been asked by the business groups, to set up an environment for their new application. And then when I would say, what's your recovery point objective or your recovery time objective? And they'd say, what are you talking about? Because they're not IT people, they're business people. And then I would, say, well, how much downtime can you handle? And if there is some kind of disaster, how much data loss can you take? And the answer always started out the same way, which is I want it up 100% of the time. I want 0 data loss. And traditionally, I would get really excited and start to, like, okay, so I got to buy a couple SANs, I got to buy the sync software between there, and I'm up at 250K before we even buy a server. And that's generally when the business person said, oh, no, we were thinking more, in the lines of under 10K. And, at that point, it was, well, okay, so you can deal with data loss, you can do, and they're like, yeah, we can handle a couple days of downtime, heck, for that money, So I didn't get to build those that often. Here in this design, we're able to give customers that high availability, that, no downtime even, and no data loss, because we're basically using 2 data centers and we're syncing that data between there. But the thing that's about that is this is single-digit responses. So, compared to some of the on-premises data centers I've worked in, the speeds between these data centers are faster than the speeds between racks in some of the data centers I've been at. And so we can take a traditional 3-tier application and we can split up the front end across those 2 data centers. Sometimes we can save money by going with smaller servers, but doing horizontal scaling if the application can handle that. On the database tier, we can do some improvements where, I have that synchronization since it's, under a single-digit millisecond. I can do replication where I'm getting a total commit from the other side before I let the application continue, where you couldn't traditionally do that in a regular data center environment because latencies were 30 to 80 milliseconds. And, the end user experience would be poor if you had to wait for that full round trip response time to continue moving on. But we can do that here. And so we can get not only high availability of something failing, it can automatically fail over to the other one. If the whole data center gets wiped out, we can automatically fail over. And the cost is relatively low. It's the cost of 2 servers as opposed to the cost of 1. So this architecture is something we build all of our services on top of. So out of those 175 plus services I mentioned, almost all of them are built on top of an architecture like this. We call it well architected. And this is something customers can build in their own stuff as they take an application, take the infrastructure and move it to our environment as well. And we highly recommend it. So that is really built and made available by this availability zone concept. In addition, in the availability zones, we have basically 2 transit centers. And that transit center is redundant, there's at least 2 of them. Those are served by at least 2 different network internet providers. And so we have multiple connections to the internet. We have multiple connections between all availability zones. The speeds are between availability zones. We have about 25 terabytes per second speeds on average, minimum. And then inside an AZ, we're at hundreds of terabytes per second traffic that it can handle. So, that's quite a large amount of traffic that it can handle, and low latency, which is important because everything that builds upon that is going to either improve or suffer from that. So other pieces in this network are what we call points of presence. And so we have 216 points of presence around the world. And these are exits and entrances into our network. So the availability zones is where we have servers and server type workloads. These points of presence, we have a cloud distribution network, and the ability to bring that data quicker and cache it so that it can be delivered faster to customers, as well as it's an entry point into the network for customers to upload data into S3 or do other types of things. And there are some workloads that can actually even be run down there. We don't have full virtual machines there, but there is the ability to run Lambda functions or some other workloads down in that space. Another piece we have is we have this global network of redundant 100 gig network connections between our data centers. And the other piece here is there's 80 locations where we have that customers can connect their networks up to, so that you get your private network connected into our network, and which gives a high security, lower latencies as you connect your internal network to our network. So that's an important piece to have those 80 locations for that. Now, what this network allows customers to do, and this is my favorite customer example, Netflix. I'll just focus on the speeds of the network at this point. For Netflix, on a general Friday evening, in the US, they push out a third of all internet traffic on a Friday evening. And they do that 100% out of AWS, out of two regions, US East 1 and US West 1. They do a lot of other interesting things, but if you think about that, 1/3 of all internet traffic in the United States is being pushed out by Netflix. And they're doing it from our network. And the other interesting thing there is they're one of many customers of ours. As they do that, other customers, such as our parent company, Amazon, you can still go there as you watch Netflix and you can buy stuff on their site, and you don't notice any difference, right? That's not tapping out and maxing out the network. As you go, if you're out and you need a ride home because you don't want to drive, our customer Lyft, you can order your Lyft and they can pick you up and bring you home. And again, just because these other customers are using a lot of traffic and doing a lot of work, it doesn't affect you as in your environment. So really neat example of just the scale that network has. And how we get there, a little bit more of the things under the covers that we do is we use custom hardware and software. Initially, we looked at purchasing and all these things, and as we learned from that 13 years of experience, we learned a couple of things. One is that we can get, by doing custom hardware and software, we can get a faster time for building new features and for improvements. But other benefits we get is we're able to get a higher availability, we're able to get a lower cost, and even a lower use of power. For example, as we looked at layer 7 switches and routers and things like that, we found that going with traditional software that we would purchase in an enterprise, it came in the firmware with all kinds of features, for different companies. Well, we only needed certain features, but these other features that were in there could possibly cause, security breaches. They could possibly cause other outages. We did find that those devices generally consumed more power than our, low-cost switches. The switches that we we're looking at 65,000 watts compared to 700 watts, right? And so we saw that we could buy and have redundant switches to every server, but at the ASIC, faster speeds, and lower cost, and not only lower cost to purchase, but lower cost to run and maintain. So in this space, everything we've done in this custom hardware and software is really to get this higher availability, lower cost, faster pace of innovation. And in the router space, I mentioned we did the custom ASICs. We do custom firmware as well. The only firmware that's on those routers is what's specifically needed for that. If that router doesn't need this feature, it won't be in there to keep them lightweight. If we look at custom software, we've done hypervisor work, and I'll talk more about that. We've done routing protocol. We built our own routing protocol for routing traffic within our network. We've also done our own firmware for multiple pieces, and we've even done our own silicone, right? So if you look at the CPUs, there's some CPUs we've built ourselves. If we look at some of the other Nitro systems, which I'll get into, it's a lot of custom-based stuff for specific reasons, really coming down to low latency, high availability. So let's look at some of that. The Nitro system is basically our hypervisor and more. Our hypervisor is built off the KVM virtualization technology, but we wanted to get near hardware performance, right? Near bare metal speeds out of our servers, and traditional hypervisors don't give that. So the Nitro system helps us with that. I'll explain that more in a minute. But so we get performance. The other thing is security. We wanted to get better security, and if you think about one aspect, just firmware. In servers, right, they have firmware, whether it's your network card firmware, whether it's your BIOS firmware of the motherboard, whether it's the hard drives, right, they have firmware. When you're in a virtual machine, how do you stop that virtual machine from reprogramming your firmware? When you think about that, I'm running on a shared server in my virtual machine, and you're in your virtual machine, and what if I upload some nasty code to that hard drive firmware? Right, so we need ways to solve that, fix that, and I'll talk more about how we fix that with Nitro. But firmware is an interesting problem for the cloud providers. And if we look at innovation, how fast can we innovate? And by doing these Nitro systems, we've been able to innovate much faster. So, what the Nitro system consists of is it initially started with networking cards, TCP/IP offload to remove all that traffic from the CPU usage just to the network card, and people have done that for years in networking. But we did our own custom card for that, get initially up to 25 gigabit per second networks to each server. And so that's where we started, but we've built beyond that, and it's actually a separate card. We add these cards into the servers. We've got the networking card. We've got a networking card for storage because our storage is remote across the network. But then management is another piece, and that one's kind of interesting. If you look at the hypervisor, right? A hypervisor, when it's doing virtualization on a server, it has to schedule time slices of who runs when. And so that takes a little bit of CPU time away from the virtual machine. It further has to look at not only when things run and that kind of stuff, but when you do something to I/O, disk, or network, there's emulation that happens. And when you do emulation, that's, instead of one clock cycle on the Intel chip and one clock cycle in the VM, you may actually have to do 40 clock cycles. So it's a significant slowdown when you emulate hardware. What we do is we've taken that piece out of the KVM hypervisor, so it's our Nitro hypervisor. We've taken the emulation out of the software and put it into custom-built ASIC chips on this card. And so one clock cycle on the Intel CPU or in the VM is one on the CPU as well, right? So because all the hard work and heavy lifting is done by a custom-built ASIC chip, which can do it faster than the Intel CPU because it's made specifically for that. And it makes it so we have bare metal type performance in our virtual machines. The other thing is monitoring and security. If we look at security, there's a couple of areas of security that that card handles. I'll talk about one in the next slide, but some of the security that handles are when you boot up. Certainly, as you look at BIOSes these days, you want to make sure the BIOS is not rewritten. You want to make sure that the operating system that you're loading doesn't have any rootkits or any other malicious code within it. And so there's ways to do that on the standard Intel hardware in the newer firmwares, but we've built that into our Nitro system. So Nitro takes care of that as well. In addition, that security piece takes care of that firmware. So we can actually update our firmwares while servers run. And we can make sure that virtual machines cannot update firmware because the connection that the machine has is a read-only connection for all of those processes running on the server. Only our Nitro card is able to update the firmware. So another piece that the security card does is Nitro Enclaves, which is a similar technology to what Intel's built, but this is done for the cloud environment where I can run in my virtual machine and programmatically have access to a secure storage space that no one else has access to, admins don't have access to, the root process doesn't have access to. And so, I can do secure storage and do it in a way that works well within the cloud. So the Nitro enables us to innovate faster. If you look at over the 270 innovations, things that we've been able to produce more instance types, basically taking new types of hardware and adding them to our network and to our environment. It takes a lot of time and effort to build a server type, CPU size and all that, and build a standard server. We've been able to increase the speed with which we do that and the testing to make sure it's secure and to make sure everything's functioning well. Nitro has made that a lot faster and easier process for us. So it does help with innovation. And if we talk about some of the machines we've built and added, I'm going to go into the CPU aspect of it, right? We have not only the Intel systems, we've added AMD at a different price point with their new processors. And then we have a processor called the Graviton, which is a custom-built processor by AWS. And that Graviton processor is on its second generation now. Basically, it's an ARM-based processor. It runs Linux. And as far as its current iteration, it's on 7 nanometer silicon. We can have up to 64 vCPUs in it. It's at a lower price point because it costs us less, so it's less for our customers to run. The performance is up by 7% and 5 times faster memory in the latest Graviton environment. But if we look at what Graviton's able to do on a 64-bit ARM chip, comparing it to our workloads with our 5th gen servers, so the M6G compared to the 5th gen on Intel, we're seeing benchmarks where we're beating Intel with an ARM-based CPU, and so that's pretty exciting. It enables low-cost work for websites and other workloads, things that will run on either platform. If you're looking at Java code or other things that don't require specifics built into the Intel environment, you're able to run those natively right away on top of these Graviton processors.
Hey, Brian?
Yes.
We're getting a lot of questions coming in. Just thought I'd ask you to comment on a couple of things. First, any sense that AWS might open up Nitro to the broader market, or will they keep it proprietary as part of your competitive advantage?
Yeah, I've run into that question before and looked into that. And so the responses I've gotten back from the service teams have been, we're open to what makes sense for our customers. We don't have any plans, at least last I asked, to launch it as a for purchase product. But we don't have any plans not to either. If there's a good market for it, we're open to selling that to customers.
Okay. So nothing right now, but keep
there's
it
nothing.
to Angel Beat, and we'll keep you updated.
Right, exactly.
And the second question came up with regard to fiber, the percentage of your backbone that's fiber. I would assume it's 90 some odd percent, but I'm also curious how concerned or how much does the speed of light literally affect the capacity and the performance of the AWS network? Mike asked that question.
So, when you think about going across the world, right, that's why we don't serve everything, out of one spot in the world from a data center perspective. I mean, certainly there's the concerns of, governments, et cetera. But if we had, if the speed of light was fast enough that, if the speed of traffic on a network was fast enough that you had 1 second late or 1 millisecond latencies, from let's say Milwaukee, Wisconsin here, and I could serve the entire world with 1 millisecond latencies, there'd be no reason to create data centers in other spots other than the power and giving jobs and stuff to other sections of the world. There'd be no point to it. The speed of light does come into play. Matter of fact, when we get beyond, 100 kilometers, 60 miles, we start to see, already that you can't get 1 millisecond or under 1 millisecond response times. If we look at traditional enterprise data centers where they may be, 400, 600 miles apart, we're often seeing 30, 50 milliseconds between those types of sites. And so, that comes into play. And as far as the fiber, I don't know of any of our backbone that isn't fiber. But I haven't really, looked into it. All the documentation I've seen then, though, is only suggested fiber.
Okay, that's good. I'll keep monitoring that, Brian. Didn't want to disrupt you, and I'll keep consolidating the questions towards the end of your talk.
Okay, great. Thank you. Another piece of silicone we have that we just launched is basically this custom-built ASIC chip that is for machine learning. And what's interesting about it is it really delivers a lower price point and faster responses for machine learning. So there's been machines, as we've done it on basic Intel machines, and then people realize, well, if I use GPUs, I can connect a lot of GPUs up to a server, and then I can get even faster machine learning, and it's really lower cost than trying to do 100 regular servers. And so not only is it faster, and whether you're doing speech recognition, image processing, fraud detection, cracking passwords, object detection, natural language processing, there's all kinds of use cases. But this is going to work better. And if we look at just a chart of how that kind of works from a cost in price performance per watt, if I look at a CPU, right, there's a lot more use cases I can use a CPU for. It's a generic type of thing. When I go to GPUs, there's less things, it's more math interested, and it basically can cost less and I can get a better performance. When we look at the custom-built ASIC chip, like this one, basically it's got less use cases, but the performance is quite a bit higher, and the cost is quite a bit lower. So these custom-built tools can really hit a certain mark, and we have been using them in our machine learning. So that's been a pretty nice, important piece that we've added. Now, if we look at what AWS is doing in regards to sustainability, we've made a commitment in September 19th of 2019 that we will basically be zero emissions, net zero carbon emissions by 2040, which is 10 years before the Paris Agreement goal of 2050. And so we've got other criteria we're trying to hit as far as that, reducing the emissions of carbon to the world. And these data centers use a lot of power. And so it's important to really focus upon this for us. We've got over 70 or nearly 70 renewable energy projects. We're looking at wind and power and that. But the other thing is if you look at efficiency, not only is efficiency important to us, I talked about like the routers, how they use less power than the traditional routers or the switches. Actually, it was a switch analysis. where we went from 65,000 watts down to 700 watts. It's a huge difference in power, and which is running costs certainly, and cooling, but it's also about that reduced footprint of carbon emissions. And if you look at a traditional data center, AWS is reduced 3.6 times. We use less energy than your traditional data center in the United States, about 3.6 times less than the average data center for basically power consumption per unit of work being done. So we're more efficient. So if we look at and summarize, what we have here in the global infrastructure, the security, it's job one at AWS. It's actually job zero is what we call it internally. And when we build things, security is always the number one importance. And when we work within and work with customers, privacy protection, security is extremely important. We have partners and customers who've been able to improve their security as they've gone from their on-premises environment into AWS. And I know that was always a pushback I would get years ago, well, if I go to cloud, I'm going to be less secure because it's on the internet. And I would completely agree with that as a technical person, as long as your traditional on-premises network is not connected to the internet. But if you're connected to the internet, I don't see much of a difference there. What I do see is we have a lot of people who are, watching for intrusions. We have people who are looking for and have dealt with, state actors trying to attack. And so we're a bit more buttoned down in process and procedure, as well as with the analysis tools than most enterprise organizations I've worked with. So customers are able to improve security generally with coming to the cloud. In availability, AWS has the highest available cloud network in the world from a cloud provider in its availability. And from a aspect, when AWS does have a problem, people pretty much notice it because Netflix and these other organizations are having a problem at that point. But that availability is generally pretty good. As if I think about it, it's been quite a while since I've seen and had those problems in the news where there was a large environmental issue that caused or screw up by us or whatever that would have caused those types of problems. That availability is quite high, and generally better than what customers are doing in their own data centers. And the performance side, I talked a lot about the low latency, about how we route traffic and we do it in a way that others generally haven't done, about the low latency between those data centers, and then about bare metal performance, right? It's getting to be in a virtual machine the same speed as bare metal. That is a huge improvement, because generally you would lose 10 to 20% with a traditional hypervisor, and so getting that back, it certainly helps that cost and that performance, because when I'm paying for a virtual machine, I get 100% of that virtual machine. From a scalability side, cloud is incredibly important, not only in its ability to scale for customers such as Netflix, right? But even, my ability to scale and handle problems and loads, my ability to, if I'm having some denial of service attack toward me, being able to thwart that. You really need cloud scale to be able to stop that, especially if it's, state actors, but even sometimes if it's the script kiddies with, using some type of botnet. It's not something your traditional on-premises data centers can withstand, but the cloud does have not only people that are trained in that, but the scalability of servers and resources to take that. And then lastly, flexibility. We mentioned there's over 175 services, which I really haven't talked about, but there's a lot of services, and building on top of our infrastructure with those services, they get all the benefits I've talked about, and you get the flexibility to build whatever you need to for the use cases out of those services. If you're looking to do something in cloud, we should have the service for you that can help you accomplish your computing goals. So that's what I have, and if there's questions, I'd be happy to take those.
Well, that's great, Brian. I'm just looking at things. I know Naresh had a question on the future rollout of Amazon's own chips versus third-party chips from Intel and the like. How do you see that trend accelerating in the future? I know you're not directly part of the hardware design team, and some of this is confidential. And as I was commenting in the chat, it was interesting to hear just a week ago that Apple has also adopted ARM-based chips to replace Intel for the next generation of Macs. So I think this trend is continuing. Microsoft and Google make their own chips on a selective basis. I'll give you my own 2 cents, then Brian, you can comment. I think as these companies get so big, as they know their applications, they're increasingly looking at developing custom hardware to differentiate their offerings, to make it more cost effective, because again, there's only a handful of companies, you can look at them in one hand, who have the scale and the resources to justify proprietary chips. You know, it's all the people on this call and pretty much no one else, unless you're like Alibaba in China. And so my own take as an outside observer with no proprietary knowledge is this will selectively increase given the scale, given competitive pressures, but it's very hard to know exactly what the future will hold. And conversely, you know, we do a lot with Intel. Intel is not going to sit on the sidelines. They're obviously aware of these initiatives, and they're going to be working really hard. I remember, and I'll date myself, back in the days of what was called the Centrino platform at Intel almost 15 years ago, where Intel didn't readily recognize the importance of Wi-Fi. That's when people used to have PCMCIA slots to get connected to Wi-Fi. Then Intel got it. They didn't want to lose the market share, and they built Wi-Fi antennas directly into their chipsets. And they rebounded to dominate the desktop market and put off a competitive threat from AMD. So I think they're going to still continue. It's awfully hard to anticipate, but I would not write off Intel and all the tens of thousands of engineers they have, because they hear from what AWS is doing. They just got the public announcement from Apple. And again, I'm just reading the headlines, and they are not staying steady. And they're going to say, look, it's fine, do your own thing in a small part of your data center, but we are going to provide resources. It's somewhat, again, analogous to Microsoft with Surface. Microsoft Surface is not going to dominate. It's not going to be the only PC you can buy, but it's going to force the Dells, the HPs of the world to innovate a lot harder. I don't know what your thoughts are, Brian.
Well, I completely agree. You know, actually, I'm on a Surface right now, working with this. But once Microsoft released the Surface, right, everybody stepped up their game and how good of a PC and machine they offered. And it's the same in chips. We've seen this time and time again with AMD, where competition forces everybody to improve and be better. So I do believe that that's the case. As far as what I see happening in the cloud with AWS, I have no idea if customers are going to be interested in the Graviton processor. If you're doing a lot of Linux workloads, you could move today to the Graviton processor without really change to your code. And so that's interesting because you can save, I don't know what the percentage on average is, but it's a significant percentage. It's quite a bit lower. It's got to be, I'm going to take a guess, about 30% or something in that range. So it's not just 1%. So there's a good cost savings to it, but I don't know that customers will do it. I do know there's a lot of things that we do inside AWS, you know, as far as building our services, as far as building things to manage our environment. Those things make complete sense to run on these chips, which will lower our cost of being a cloud provider. And so that, you know, I will see, I'm sure, more and more of that used in our internal infrastructure that customers don't see. They just, you know, get the benefits of the network and of the servers and all that and of the management. But as far as whether customers will use it or not, that remains to be seen.
Another question came up here. This is from Andrew, talked about why would anyone go multi-cloud? And given some of your experience at Microsoft and Amazon, maybe you can comment that. I know as one specific case in point, if you look at the history of cloud computing, AWS was the leader. They've got currently the dominant market share. And then you might have situations, let's say there's SQL Server end of life taking place right now. So a lot of people are now saying, you know, I really don't want to worry about managing my own SQL Server. I'm going to move it to the cloud. And then people have choices. A lot of times, because of Brian and his team, they want to just run these Microsoft apps on AWS. Sometimes they may feel a little more comfortable with Microsoft and they just move it up to Azure. I think it just depends on the exact situation. There are cost issues, there are strategic issues, keeping that in mind. Maybe you could comment, Brian, on some of your clients who, even though they love AWS, how do they coexist with an Azure or GCP or IBM cloud configuration?
Sure. Yeah, you know, having worked in the industry, right, customers don't want vendor lock-in. They like to have that choice. And so people have talked about multi-cloud a lot. Initially, what I saw with multi-cloud was with the tools a couple of years ago, I thought it was a detriment in the sense that you're not able to take advantage of what the cloud really offers. Yes, you go into Azure Functions or Lambda Functions, right? And you basically can't just move that out to something else, but then you get a lot of benefit by lowering your costs and only paying for the compute power that you need. So I thought it was a mistake to go multi-cloud. What I see customers doing right now, a lot of customers want to go to basically a microservices architecture with applications doing Docker containers. And part of the reason behind the customers that are deciding to do that, well, it is complex, and it would be easier maybe to go to just a Lambda type environment. They're able to do it on premises. They're able to do it in anyone's cloud, right? And function very similarly in all of them. So I do see some customers, that want to be able to stay vendor agnostic, looking to do that type of containerization. That said, I work for AWS, and our position really is that what's your use case, and if it does make sense, but we haven't found a use case that makes sense. We're an offering that we lower our prices when we reduce our costs. We you can tie into services like S3 and to other features that can help save costs in your apps. And so, we generally don't talk about multi-cloud and don't suggest it. But I have seen a lot of customers doing that with Docker containers as a direction.
I guess just to amplify, because we see that a lot, there is some strategic rationale or financial considerations. Think, well, I want to keep AWS honest. I want to keep Microsoft honest. As I said, a lot of people in the IT, all the traditional AngelBeat attendees, tend to get a little nervous of vendor lock-in. I think the question is, and this is where AngelBeat can help, it all depends on your individual circumstances. Again, you may have an IBM mainframe application running COBOL where the complexity of moving to cloud is too hard. It may just, because of the risk, may make sense to keep that within IBM and work in the cloud, but it may make sense to take advantage of all the other solutions you're already using AWS for. There's no right or wrong answer, and I encourage everyone, you can contact me, Ron Gerber, just rgerber@angelbeat.com. We'll make sure that you get the answers you need, and in doing so, then you can make an informed decision. And a lot of organizations say, look, it's simplified. I just want to do it with one vendor. I got it covered. I trust them. And that makes sense. Some people may make a different decision. And again, we just at AngelBeat want to provide you with the insights you need to make that happen.